So today we're going to learn about another gate. But before that, let me ask you a few questions quickly. Salman, what is the definition of a NOT gate? What is, like, let me put it this way. What is the logical expression for a NOT gate? Give me the equation. X. Good. Good. Okay, next. We have what is the symbol for a NOT gate? A NOT gate. Yes. A and X. Next. Yes, it's called the symbol of the gate. Yes, symbol. Next we have Amr. What is the logical expression for AND gate? What is the symbol for it? D shape. Yeah. Good. Ali, what is the table, the truth table for an AND gate? 1 minute, 1 minute. So 0, 0 gives us 0, 1 gives us 1, 0. It's dot AND gate. No, this one. This is separate. Yes. Good. So this is AND gate. Yes. Good. Okay. Next one we have is OR gate. Musjil. We have for OR gate. We have X is equal to A or B. Alternative equation. Muaz, what is the symbol for it? OR gate.
Like this and then like that.
Good, good, good. This is not A and B. Good, 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 good. Now, start again from there. What is truth table for OR gate? Start from there. I'm coming to you. Yes. 0, 0 gives us what? For OR gate. Not for this one. For OR gate gives us for 0, 1. 1, 0. 1, 1. Good. Don't say it, both of you. Good, 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 good. Well done. Nice guess. Okay. Next one we did NAND gate. The reason I'm going through again and again because we are going to implement it in today's lesson. So if you are good at individual ones, you can make your own circuit. End of this chapter after this, inshallah. What is the property of NAND gate? A NAND gate. Give me the expression, logical expression. Bar on top. Good. A dot B and bar on top. That means we get the AND gate first, the value of AND gate. Both of them. Either or either. One is American, one is British. Either is, because whichever is easy, the pronunciation, that's American. Just simple rule of that. But if it's, which one has more tricks into it, that's normally British. What is the symbol for a NAND gate? We have normal AND gate, except we introduce a bubble here. So that basically inverts the value of the AND gate. No, it's a circle, not a sphere. Okay, a bubble, yes. Next, we have 0, 0 gives us what? For NAND gate. Remember, because 0, 0 gives for AND gives us 0, so invert that value. 0, 1, because 0, 1 gives us for AND gives 0, we inverted 1. 1, 0, and 1, 1. Good. So the trick here is invert all these values to AND first. Whatever you get it, invert it. Okay, good. Yes, sir. Yes, yes. Good. Well done. Well done. Okay. Now, the last thing we come back to here. It's exclusive OR. Exclusive OR logic gate has two inputs, as normal we have been studying, and one output. Now pay attention to this one. The output is only one when one of the inputs are 1 and the other one are 0. So if both of them are same value, for example, both of them are 0, both of them are 1s, then we get the output as 0. Let me go take you to the table first here. Notice here we have 0. We have 0 here, we have 0 here. If both values are the same, and here we have 1 and 1. Change the color. So we have 0 here, 0 there. This is going to give us 0. 1 and 1 is going to give us 0 as well. So wherever, when both inputs are zeros, we need to get the output as 0. If one of them are different, then we get 1. That's the definition of an exclusive OR. It has to be only one of them are 0 and the other one has to be 1. Going back, the symbol looks like the same as OR, except we add this line to it. So this is now how we draw an exclusive OR gate. This one. Exclusive OR. XOR, exclusive OR. Earlier we did OR, we did NOR. This is called exclusive OR. Okay? Now we have the expression x is equal to, we write it exclusive OR B. That's one way of writing. The other one we have x is equal to A and symbol, look. X is equal to A. This is for OR gate. This is for OR gate. To make it exclusive, we just write like this. So O exclusive gate and then B. Now, in light, sometimes, I don't know if you have noticed, when you have 2 floors, you have stairs. Normally in the stairs, the light can be turned on and off from the bottom floor and the top one. So both of them, they can't be on at the same time or off. One has to be off, one has to be on. So a light turns on only if one switch is flipped, not both or none of them. So one or the other. In cryptography, we use exclusive OR as well, but that's advanced. It's just example. If you ask where you can use them, so we can use them in cryptography as well. Now, I'm going to help you with this first question. The second one, I'm going to give you. Now, I want you to get your notebooks out and draw it like this. And then we will solve it together. We're going to solve it together. We want to convert this circuit into a truth table. But write this first down. We're going to solve it together, one by one. Do it now, quickly, please. Which one? B. A, B, C. E, the inputs. This one. It's a gate, one of the gates. Okay, good question. Let's do it one by one, then we give time. Let's draw it first. I'm going to explain to you. Let's draw it first, and then we'll go through together. Okay, which gate is this? AND gate. No, it's not AND gate. Not gate. Only this one, not gate. It's a not gate. This one. OR gate, okay? Because the Q is the final output. This is what we're going to find out. And inside this working place, this is what we are going to do these different calculations. First step we do is, to make it easy for us, we go here. We're going to calculate these two. So I'm going to call this D. Before that, we're going to calculate this one here. So I'm going to draw it like this. I'm going to call it not B, which means B and bar. So what's going to happen is, this is going to change into here. 0 will change into 1, 0 into 1, 1 into 0, and then 0, then 1, then 1, 0, 0. So we inverted all the values of B into not B. So this becomes a not B. Now the not B will go with C as input in this AND gate, which is going to give us a D. We give from ourselves. So I'm going to call this D. What? No. B is going to be inverted. So 0 becomes 1, 0 becomes 1. Okay? Whatever the values here of the B, we invert those into inverted numbers. Now next one we have D, which is equal to not B. So D is equal to not B and dot, which is an AND gate, C. Okay? How do we do that? Let's see. So you have this one, this one. We're going to do calculation this one. 0, 1 gives us, remember it's an AND gate. 0, 1 gives us, for AND gate, Ali. 0 gives, 0 and 1 gives us for AND gate. 1 and 1 gives us, Salman. 1 and 1 gives us what? 1.1. 1 and 1 gives us 1. Isa. 0 and 0 gives us what? Isa. 0 and 0 gives us 1 and 0 gives us Bilal. 0, because it's AND gate. Remember AND gate. 1 and 0, Abdullah. 1 and 0 gives us AND gate. AND gate. And 1 and 0. 0 and 1. 0 and 1 AND gate gives us 1.
Understand how the last two are. When you say that it's 4, then so long as one of them is 1, then they're both 1.
No, this is not always AND, not gate.
Look at the last one, it's 4. Then you said that A is 1, so long as A is 1, then B is 1.
It's B, not B, dot C. Dot is, that's going to go next. Third step. First step we did is converted B into not B. Second step we converted these two into AND gate. Abdullah, 0 and 1 gives us, for not gate is 0, not 1. 1, 1, you said no, you said 0. You said 1. Which one?
A is the 1. If A is 1, then it should all be 1. Then it should be 1. The answer should be 1. And the last one is 4.
This one? This line?
If A is 1 on the very left,
We haven't touched A yet. The third step, we're going to touch A with D. Because this is how it's being processed. You can't deal with A with D because you haven't got the output from yet. So you have to do it chronological order. Okay, good question. Good question. The OR gate comes the last stage. The AND gate comes at the one before that. And the NOT gate comes first. If you have 0 here, let's suppose here is, you are right. All of them can be 1 here for these 4. This one we don't know yet. So you are half right. For this one, we can put it from now, it's 1. But the top ones, we don't know yet. What I just said now. From beginning, we could do that. From here to there, we can put 1. It's fine. but from here to there we don't know yet. D is equal to B not B dot C. So we have C, which is 1 1 is going to give us 1, 0 0 is going to give us 0, 1 0 is going to give us 0. Now the last one we have, where we want to have it, which will be Q is equals, we have A, and it's going to be OR gate.
At least you took one, right?
Yes, no worries. Now we want to have the one value coming from D, and one is going to be D. So that's a D. Now what we do here, compare this one with this one. As Muaz said, we can put these one, because of this one, we can put first these top bottom ones, regardless if we have ones and zeros, because if OR gate, we can just put simply one. That's fine, no problem. The problem comes here. 0, 0, OR gate. 0 and 0 gives us 0, OR gate. 0 and 1 gives us, Ali, 0 and 1 gives us what? OR gate.
This one. With 0 and 1, okay, 1.
0 and 0 gives us OR gate. And 0 gives us 0. You see here? Now we have done, solve this step by step. This is our final answer. Write it down. Copy this one now. Good. It's 0 and 0 gives us 0. Well done.